Today I'm going to talk about nodes in the network. It's going to be quite a modern approach, and it might differ slightly in some of the terminology used by Brendan and Jad. And it's going to be a little bit about the topology of the network and also about the kind of the language we use when we describe the network. And I by no means want to appear like I'm policing anyone's use of language, but you might hear some people like Steve and Craig, when they're trying to be very precise, they might use terminology you're not quite familiar with. So I think it's a good exercise to understand maybe why that is. Okay, so I'm going to start with the punchline, really. Well, two punchlines. So firstly, there's this figure on the left, and this is taken from a Bitcoin SV Wiki article called The Bitcoin Network, which I wrote, but that was in collaboration with Craig and approved by him. So let's say that's by me and Craig. And I'm going to use a few quotes from that article as well. It's only around a page long, so I'd encourage you to have a look at that if you're interested in some of the things I'm going to talk about. Anyway, the first kind of punchline is that this figure on the left is actually a reasonable representation of the Bitcoin network. And it's not a simplification, just it is as simple as that. And the second punchline really is on the right, which is the title of the white paper, Bitcoin, a peer-to-peer electronic cash system. And it might not mean what you think it means, or I mean, it certainly, I think, caught me by surprise when I realized that the term peer that the title is referring to is not a peer-to-peer payment between two users, but it's a peer on the network of nodes on the left. Okay, and just to kind of clear something up, the Bitcoin white paper was written by me, Owen Vaughan. Okay, so the first section is on nodes. I'm going to try and represent by these little blobs on the left. So other terms for nodes are block producers, or also they're commonly called miners. So I'll start just with a little quote from this article. So the Bitcoin network is made up of one and only one type of node that is defined by section 5 of the white paper. So I think Brendan did a great job earlier of going through section 5. I'll just pull out a couple of bullet points here. So the third point was each node works on finding a difficult proof of work. And when it finds this proof of work solution, it broadcasts to all other nodes on the network. So the white paper is kind of quite clear that this is how you define a node. Nodes are often referred to as miners. And actually the white paper, it does mention mining. It makes an analogy between the expending resources to find a difficult proof of work and being rewarded with new coins as analogous to mining. It doesn't itself call nodes miners. Anyway, they're characterized by an ability to produce a valid block. And I use the word produce here quite carefully, rather than a term mined or won, because solving this difficult proof of work algorithm and everything that goes before that Brendan mentioned, by gathering together transactions, validating them, and constructing a block, all it does is allow you to produce a valid block. It doesn't mean the other nodes are guaranteed to accept it. For example, it might violate their own local policies. For example, it might be too big, or it might violate some other more legal aspects, like it might contain a transaction that within your jurisdiction has been ruled illegal. And this is one of the reasons why you have to wait 100 blocks for your mining reward to mature and to be able to spend it. It's so that you have time to do this type of forensic audit of a block that goes beyond just checking whether or not a transaction is valid. And nodes distribute blocks to their peers. And this is because the distribution refers to how the reward is allocated. On the other hand, you can say that miners propagate transactions because they refer to other people's money being registered and propagated. Okay, so here's a statistic some of you might be familiar with on a chain analysis website called CoinDance. And this statistic is referred to as the node count. So you see BTC by far has the most network nodes according to this metric, then BCH, then BSV is last. However, these are not nodes according to the definition I've just given you that's based on section 5 of the white paper. These are machines that run node software. And that's fine. I mean, they're an interesting network to consider in their own right. But I just want to emphasize the fact that they aren't engaged in the proof of work difficulty or the consensus mechanism. So here's our kind of first observation, that when we talk about the Bitcoin network, there are really two networks at play here. One is the Bitcoin network as I have presented it. That's based on nodes that are block producers. And the other is, I mean, I'm still finding the right terminology for this, but for this talk, I'll call it the Bitcoin gossip network, because you can consider them as part of a gossip peer-to-peer protocol network. And if it helps, then you can refer to the first network as Bitcoin consensus network. And one is not necessarily a subset of the other. So the Bitcoin consensus network, you have to take a subset of the gossip network, but then perform another aggregation. So it's not quite as simple as just one thing inside the other. I'll talk a bit more about what I mean by that later on. So this is a kind of first observation. Okay, then I'd like to talk about the consensus mechanism. Nodes are responsible for upholding the consensus mechanism of the system that's based on block publication and proof of work. And I really want to emphasize how crucial block publication is for the Bitcoin consensus mechanism. If blocks are not published widely, then it's difficult to provide evidence about what events happened and in what order. And you might ask, how do you provide evidence that blocks have been widely publicized? Well, you can just simply ask people. So as a kind of thought experiment, so we all know that the Bitcoin blockchain in the Genesis block contained an article from the Times newspaper in the UK. But suppose someone came along and said, well, actually, I say that it contained an article from the Guardian newspaper, which is another newspaper here. And in fact, I have a longer proof of work chain to prove it. And by length of the proof of work chain, I mean the most kind of aggregate hashing done on that chain. So we have two competing chains. One has more proof of work that says the Genesis block contained the Guardian newspaper. And how would we make a counter argument? Well, we'd simply say this isn't true. Like everyone knows that the Bitcoin blockchain has a Times newspaper. We've all seen it. It's been written about. People have sent transactions that will be either spending Coinbase or block headers derived from that Genesis block. So let's say the security of the chain or the immutability of the order in which events have happened critically relies on the publication of blocks. And I couldn't think of another good example other than a counterexample. And this is, I like to think of Bernie Madoff, who ran the world's biggest Ponzi scheme. And he would run competing private databases and only show certain people certain databases. Okay. And this relied on the fact that these data structures were not widely publicized. And in a kind of cruel example of history repeating itself, Bernie Madoff was a market maker on the NASDAQ. And a couple of months ago, I noticed that the NASDAQ are teaming up with R3 Corda, which is a private ledger, to transfer their platform onto. So it seems like perhaps lessons haven't really been learned from that. Okay, and now I'd like to take another statistic from CoinDance, and this is the hash rate. So the time when I pulled this statistic in May, you see BTC is much more dominant with BCH and BSV around a similar amount of hash in kind of 3 to 4%. And you might kind of ask yourself, well, is this a problem? Or, well, put it this way, it hasn't really been a problem. We haven't noticed any detrimental behavior of the system based on this hash rate. I think it's worth asking the question why that is. So I can kind of see it on two reasons really that are all based on block publication. So firstly, if there are certainly these chains are split on political lines, and there are people who might like to say disrupt the BSV chain by, for example, mining empty blocks. And if you're part of a mining pool, as most mining organizations are, and you started mining on the BSV blockchain where it was less profitable, then, well, you might run into some complications, because it would be immediately obvious here on CoinDanch. You could see that your mining pool was mining on a chain that at the time would be less profitable. And you might have something to say to the board of directors of your mining pool company might not like that. And in fact, they might also have obligations to their shareholders. So in this sense, it's the open block publication mechanism that might prevent something like that happening. Well, you could say, well, maybe you're an individual with enough resources to just start your own mining pool on BSV, and then were again engaged in some activity that was seen as detrimental, for example, mining empty blocks or selfish mining or containing transactions that were not legal. Well, then that would be obvious to the other miners on BSV, and they might choose to reject blocks coming from the miner in question. So the security of the chain is really critically reliant on block publication. Now, how are blocks published? Well, in a data structure that we call the blockchain. And the definition of a blockchain is with respect to this Bitcoin consensus mechanism, which is based on block publication. And with this definition in mind, there really is no concept of a private blockchain. A blockchain is the data structure associated with the Bitcoin consensus mechanism. And it's a term that maybe is overused at times. So here's, I was just reading a couple of blogs by Steve a couple of months ago that were on a completely different topic on the user stress test and transaction fee economy. And they're interesting to read just by analyzing the types of language Steve is using, because he uses the term blockchain just once in these two blogs. And it is really specifically to refer to the data structure, right? I think he says something like a massively scaled blockchain. He uses the term network around 35 times. So often it's the Bitcoin network that might be more appropriate when we talk about transactions being sent to the network, registered at nodes, and published on the blockchain. Okay, the next section is on the topology itself, which, as we all know, is peer-to-peer to peer-to-peer. And I mean, this is half a joke, but I mean, if we have a peer-to-peer payment that goes on a blockchain and then is propagated from one peer to another, then this is kind of not a wrong statement. But I'm also trying to make the point that the term peer is used quite a lot, but it should really be said with respect to a particular network that you're talking about. Okay, so nodes are incentivized to maintain a high degree of connectivity with other nodes. And this means that the network topology is that of a nearly complete graph. So Brendan talked a lot about this earlier, but just to kind of remind you why they are incentivized to do this. Well, firstly, it's to make sure they always build on the most up-to-date block. Secondly, it's to collect transaction fees. And then thirdly, they want to propagate transactions to reduce the risk of their block not being built upon. Otherwise, they might have contractual obligations to do this to a enterprise level customer under which they have entered a service level agreement. So they really are incentivized to be highly connected with other nodes. And at any one time, there are typically less than 10 nodes that publish the majority of blocks. So I think it's worth talking about this. Is this really reasonable that there are less than 10 nodes? Well, the difficulty adjusts every 2 weeks. So if we take at any one time to mean a 2-week window, which kind of seems reasonable, then you already have an upper bound of around 2,000 nodes, which is the maximum amount of blocks in 2 weeks. And I think similarly, if you haven't produced a block in 2 weeks, we can say that you've dropped off this network. However, due to infrastructure challenges, there are really more than around 20 nodes on the network. And certainly the majority of blocks is produced by less than 10. So this leads me on to the graph on the right. And this is really a reasonable representation of the Bitcoin network. old nodes may drop off at any time and new nodes may join. So there's no hierarchy in the process of block production or validation, making it like truly a peer-to-peer network. Okay, so this section is called the fine structure of a node, and it's kind of a play on the hydrogen atom on the left. So if you ever study physics like I have, you might have looked into how you can derive the structure of the hydrogen atom from quantum field theory, and that's kind of what this is about. So if we looked into a node, what would we see? So there's no requirement for a node to be made up of a single machine, and in fact, nodes may be made up of several different link systems, including routing database and processing modules. And I think Jad touched on this earlier very nicely. So I've pinched a couple of images from a talk Daniel Connolly gave about the strategy for the SV node software. And it was first to scale up, so to impose larger requirements on a single machine. And then it's to scale out, so we have many copies of this machine. So a node doesn't necessarily mean one single machine. But it's kind of even worse than that, because say we can no longer talk about single machines. We could think of a node as an entity running node software. But it doesn't have to be one entity, it could be two. So most mining pools will have at least one backup. So they're going to have at least two entities running node software. So what on earth is a node now? It's getting a bit difficult to kind of conceptualize. So to me, a node is a system that within itself agrees upon the following things: whether an incoming block is valid, the order in which transactions are registered, and it produces blocks originating from the same address. So this address could be a miner ID, it could be some other form of public key identity, it could be a collection of IP addresses, or it could be something else entirely, another way to kind of classify this entity. So this kind of leads me on to the first punchline of this talk. So this diagram of the topology of the network, we can now give a bit more of a concrete definition of these nodes. So a node could be many entities running node software, and they're defined by agreeing on the same local policy. So within this system, no block can be rejected by another entity. And an edge, this is just my own terminology now, I think of it as a consensus edge, which can be made up of many-to-many IP connections, but it's characterized by along an edge, a block may be rejected. And I gave this talk internally, a colleague of mine who's an economist, Ahmed Alagishiev, I think he made a good description of this, where he said a node is a representative agent of a community of block producers. And that's probably the best kind of summary I can give of what a node is. Okay, the last section I'd like to talk about is users. In fact, at the moment, especially say in BTC, users may actually run node software themselves, and that's the process they use to communicate with actual Bitcoin nodes to get their transactions in. But it doesn't have to be. For example, you could send a transaction to the what's on chain node through their API, or you could use Mappy that my colleague Jad was talking about earlier to submit transactions directly to nodes. I think users are best described by just simply examples. So a user could be a service provider, like a social media network, could be a storage entity, an autonomous agent, or you might call this a smart contract, or it could be wallet software. These are all examples of users, and notice that none of them are actually, human beings or even your grandma or anyone like that. They are software processors. And users don't play any role in the production, distribution, or the validation of blocks on the Bitcoin network, and are therefore not involved in the consensus process. Users themselves, they don't have to be part of any network in a formal sense, but there may exist, in certain contexts, complex user networks that are separate to the Bitcoin network. And a user may well be a node on their own network whilst being a client on the Bitcoin network. Sometimes if these networks can be thought of being overlaid on top of one of each other and of the Bitcoin network, they may form a structure called a Bitcoin layered network, which is something that Craig described in a talk at CoinGeek in February. Okay, so that was it really. I wanted to finish on the slide I started with and just kind of re-emphasize these two punchlines, that this diagram on the left represents the Bitcoin network. These nodes could be collections of entities running node software, which themselves, each entity could be made up of many machines. And the title of the white paper is referring to a system of nodes or peers maintaining this form of electronic cash. So thank you very much for listening. And I'd really like to keep this talk short and give you guys the opportunities to ask any questions.
Hello. Sorry, I'm just going to share the screen with the questions.
Mm-hmm.
And I've got one more that's just come in as well. So, Owen, this one I think is particularly interesting. The topologies of the BTC and BCH networks, are they similar to BSV?
I see. Yeah, I mean, they are similar in certain respects. So they'll have a similar node count. So if you just go on CoinDance, you'll see that the number of miners and roughly the proportions of hash rate they have is very similar to all the networks. So there will be typically, say, less than 10 nodes producing the majority of the blocks. In BTC, there isn't such a burden of connectivity on the nodes. And this is because of their very small block size and low transaction throughput. So it's not such a problem if nodes aren't directly connected to one another, and they may well not be. It's also not such a problem because they have moved away from instant transactions because they're replaced by feeds. So their whole network latency is much higher. BCH is a bit more interesting, and I think they may have a few more issues with this because they are or propose to get towards high transaction volumes, but they are implementing other features that make mining slightly more anonymous. I'm thinking of features like canonical transaction ordering. So they'd like to have larger blocks, but at the same time, it might be trickier to identify miners. Therefore, again, you may not have these direct connections between miners, and that can be an issue when it comes to instant transactions, right? Because if you have someone in the middle of these transactions or a higher latency between miners, then it makes double spend attempts, it reduces the difficulty of them.
So one thing that I've probably noticed about about the Bitcoin SV network is you could probably broadly categorize miners into the ones that have been mining Bitcoin SV for quite some time and probably are quite interested in Bitcoin SV as a network other than just as a potential source of revenue. And others who are probably more primarily focused on other SHA-256 chains. And Binance is a notable one that has recently entered the mining fray on Bitcoin SV. Something that I noticed is that they mine a very large number of very, very small blocks with very few transactions in them. And my theory on this, well, it's more of an educated guess because I don't have any access to their systems, is that they are probably quite poorly connected out on the edges of the network. I initially thought maybe they just had their mining pool set up this way, but they do occasionally pick up a large block. I've seen blocks up to 8 meg, but regularly they're 20, 30 kilobytes. And so that suggests to me that they don't have a very fast conduit to the core of the Bitcoin SV network, which is actually not so much a problem from our point of view, but is potentially a problem from theirs because of all the revenues that they're missing.
Yeah, and if you're it's a good point. If you're a user and you had the choice, who would you prefer to send your transaction to? Someone who seems to demonstrate quite a low level of connectivity, or another miner that might be quite highly connected. So I could imagine in the future, users will be more demanding about the level of connectivity their miners can demonstrate to have. So it might be in a miner's interest to try and improve that if they can. So they might get ultimately more revenue from users.
Certainly. It's also in their interests in terms of the raw economics of mining as well, being able to propagate their blocks quickly, but also being able to receive other miners' blocks rapidly as well. Because until you've received and validated a block, even if the rest of the network is already working on it, you can't start building on top of it safely. So you lose when you're trying to send blocks, and you also lose when you're trying to receive blocks if you're poorly connected. So I've got another question from John Pitts, which is not really focused on the topic of your talk, but it's an interesting one nevertheless. He asks, when Terranode and Chronicle are released, will the false op return script pattern be more like a hack rather than a useful script? I guess he's referring to Chronicle as the hard fork upgrade, where we're planning on restoring the original difficulty adjustment algorithm, but no date has been sort of targeted for that upgrade yet. So what do you think about false op return as a script pattern for data storage?
I suppose the alternative is to include this in a spendable output. I'm struggling to see the advantage of using this more traditional script pattern, especially as it gives you an obvious green light for a node to prune that particular piece of data. So yeah, I think I could kind of broadly agree with, I think, the sentiment of the question, that its utility might be reduced going forward. But the good news is, I think the way in which we use these scripts doesn't need to alter, right? You can just stick a checksig in before that, and then an op return, and then your data, making it a spendable UTXO, but with the same type of data storage.
Yeah, in fact, you can end any valid Bitcoin script with op return and get exactly the same result, and then append data to it. So there's a few different techniques available there. So Richard asks a question: how do Bitcoin layered networks fit into the picture?
Yeah, okay. Thanks for the question. I roughly anticipated this, so I put in an extra slide that maybe I can just bring up if I still have the time. So hopefully that's gone back to my screen. So Bitcoin layered networks. I don't know if everyone here caught the talk by Craig at CoinGeek in February on this topic. If not, then you can get that on YouTube. But they are a way to overlay different layers of network on top of the Bitcoin network. And this is just, I think it's best described by this diagram, really. So in the center, you can see the Bitcoin network forming a complete graph in this case, with different layers. So the first layer is connected directly to the core. You could think of these as service providers. And the second layer might be, they're connected to one layer one node in the layer above, and also directly to the miners in the central core. These could be your wallet software providers, and the outer layer might be your users. And this is an example of a network that is separate from the Bitcoin network, but builds on top of it. And they're done in a certain way. This diagram here is actually very specific. It was kind of inspired by a paper called Mandala Networks in 2015. So a mandala image is roughly speaking a pattern based on concentric circles, which is why it kind of looks like this. And the paper itself was very, very specific and rigid in how it defined these mandala networks, like the amount of nodes you could put in layer 3 depending in a very specific way on layer 2 and layer 1 and so on. So we want to take inspiration from that and keep the good parts, but make it slightly more general and applicable to Bitcoin. And they can be characterized by, if you were to construct your network in this way, you can show that it satisfies certain advantageous properties, such as being ultra small world and highly sparse. So the sparsity really means the burden of connectivity is placed on the innermost ring here. So miners have to have the highest connectivity, then layer 1 the next highest, and so on, until your end users don't need to be that connected, maybe just to their service provider and some other users. And they also display a high level of robustness or Byzantine fault tolerance. So this is just kind of, I think, an initial investigation into how you could, in a scalable way, introduce many more actors onto a network that is built on top of the central core of Bitcoin.
Okay, and we've got one last interesting question here, which we'd like to address. I'll just get you to unshare your screen for a moment. The question comes from Phil, and I'm wondering if it's maybe Phil Wilson of Scronti fame. So I heard this myself. Did Owen really say at the beginning of this presentation that he, Owen Vaughan, wrote the Bitcoin white paper?
No, Phil, you must be mistaken. I think I wouldn't say something like that. I mean, Satoshi is female, so for a start, it couldn't be accurate. Just a little joke.
You need to spend some time with Owen to get used to his sense of humor. Well, I mean, if it is Phil Wilson, then yeah, I can imagine he's up in arms right now. So one last one. How can you identify the Bitcoin consensus network within the gossip network? And we were talking about this just the other day. The confusion that arises because there are words that are used that actually accurately describe different things, but people then assume that you're referring to the same thing.
Yeah. Yeah. So there's a few different approaches I can see one taking. One is by well, I think it's worth pointing out, to directly identify this network, you have to be a node, or you maybe have to get the complete picture that every node or miner sees. So that could be very difficult to actually obtain. But you can do indirect measurements. For example, you can ask a node which node they're connected to, and then which ones they're connected to, and so on, to try and get a indirect measurement about how these miners are connected to one another. Otherwise, I think you could probably try and do some very interesting analysis by submitting a transaction to a certain sample of nodes, and then very quickly submitting a double spend of that transaction, and trying to do some statistical analysis about which IP addresses pick up which transaction. But I think it's also worth pointing out that you might not need to, right? When we've introduced things like MAPI, you can submit transactions directly to these mining nodes without having to go through the Bitcoin network itself. And you can be assured that they will be highly connected to other miners.
Okay. We have a couple of other quite interesting looking questions, but we have run out of time. So I'm told we have time for one more. Do you expect that nodes will become general purpose processors to run smart contracts, perhaps with custom ASIC processors optimized for Bitcoin script?
Yes, I don't see any reason why they wouldn't, right? If you're a node, you probably have a lot of very expensive equipment geared towards transaction processing, and in particular, processing script in the script engine. So as we talked about before, there's no requirement for a node to be one machine. So you could introduce some more modules running in parallel that are processing smart contracts, for example. And it seems to me like this could be another source of revenue for a miner. And it wouldn't surprise me at all if in the future you start to see some of the more established miners, particularly on BSV, so people like Tal and Mempool, also branching out into things like smart contract processing.
I think one of the most efficient ways to actually make use of any kind of constrained resource that has peaks and troughs in demand is to actually maintain steady state usage of it. So when you've got pools of processing work that are variable and pools of processing work that aren't very time sensitive, you can sit there with queues of work waiting until the demand drops and make use of that unused capacity, and keep your assets basically working at their peak capacity the whole time. So thank you very much, Owen.